exciting work that I know from Rutgers. And also, because I know Smara for so long, I don't know to what extent she wants us to be known, but we went together to kindergarten. So it's really great to be with her every time I get a chance. And what I would like to talk about today is work that we've been doing in my group at North Texas on using Wikipedia for natural language processing. And since I figured that there is a good likelihood that you might not know a lot about the work that we are doing here, I want to do a very brief introduction to the kind of research project that we have in my group, and then I'll focus on this particular topic. So we mainly focus on research in natural language processing, although we also do some work in information retrieval and okay. We also do some work in applied machine learning and information retrieval. The group that I'm heading at North Texas right now consists of 10 PhD students and 2 master students working on a number of projects. And one of the main project umbrellas, I would say, is work on graph-based natural language processing. And I think this is an interesting view that you can have when you look at text. You can see the kind of relations that exist between different entities in the text. And these entities could be words, could be word senses, could be sentences, could be entire documents, and then the relations that you can draw between these entities could be semantic relations, could be some form of relatedness, overlap. And based on how you build your graph or your network, you can solve different problems. So problems that we look at are word sense disambiguation, figuring the meaning of words, keyword extraction, finding what are the words or phrases that are more important in a text, summarization, coming up with abstract. And just to illustrate here some of the graphs that we are looking at, this is the graph of the translations and different synonyms for one word, the word plant. And based on this structure that you are coming with, you can do very nice application in, for instance, translation or expanding text with synonyms. We are in particular working on lexical substitution, like replacing words with semantic alternatives or finding translations. And hopefully in the long run, this is something that could be useful for English as a second language learners. That's something that we are looking at right now. Here is another example of input data. So this would be a text, and you can take the sentences to be the entities that you are looking at to form the graph, and then some form of similarity between sentences to form the relations. So you can come up with graphs like this. And then on this, if you apply some graph algorithm that would find the centrality of the nodes, what are the nodes that are most important in this particular graph structure, you can actually create summaries. So in this particular case, you would have these 2 sentences that would be the most connected sentences. So eventually you would say, if I only read these 2 sentences, I'll probably get an idea of what the text is about. So that would be a good approximation for a summary. Another project we are working on is multilingual subjectivity analysis. And more recently, I started also working with people on multimodal multilingual subjectivity analysis, so also looking at other modalities. And here the main idea is that we learn a lot by looking at English. For instance, we have very large lexicons, we have a lot of annotated data. But then if you look at a language like, say, Romanian or Spanish or French, you don't have all those resources for this particular task, but it's the same for other tasks. So one thing that we worked on was what we can do to transfer the resources that are available for English to other languages. Like, for instance, English lexicons, which would indicate, for this particular project, would indicate whether a text is subjective or not, whether it expresses an opinion or it's just an objective statement. So one thing, you can translate dictionaries. The other thing is to start with data that was annotated for opinions. So you have a clear indication, again on English data, whether a certain sentence contains an opinion or not. And based on that, somehow you manage to create a similar resource in your target language, whatever that is. And then once you have that, then you can do the different methods that were applied on English. You can also apply them on that other language, whatever it is, Iranian, Arabic, French, and so on. The more recent work that we are doing there, which is a direction of research that really excites me, is the fact that you can actually learn even more if you look at multiple languages at the same time. So the traditional direction, which is what we spent most of our time in this project, was to start with English and then move to another language that is less resource rich. But there's something that we notice almost incidentally when we run a very small experiment, is that actually for some task you can learn more from another language. And one thing that we did was this experiment where we had, again, finding opinions in text, and we had the very same data that we are learning from in English and Romanian was translated by hand, so the quality of the translation was not an issue. We had the very same test data. We used the same machine learning algorithms, whatever they are, it doesn't really matter, but everything was identical. The only difference was the language. In one case, the language was English, in the other case, the language was Romanian. And the thing that we noticed was that in Romanian, we did 8 absolute percentages better than in English. So it was really about the language, the fact that in Romanian, certain things are more clearly expressed. And thinking of explanations, it could be, for instance, that in Romanian we do have clear expressions for politeness. We have 4 different forms for you, whereas in English it's all you. Whether it's singular, plural, whether it's polite or not, it's still you, whereas in Romanian you can tell apart those different shades of politeness. And there are many other things, cases and other things that would be more overt in Romanian versus English, and that made a difference. So the one thing that we learned from that experiment was actually that some languages are better at certain phenomena, linguistic phenomena, so we can maybe do even better at this big English language, which is a major language, and there are no doubts about that. But sometimes English itself can learn from other smaller languages. That is something that we are working on. We did some experiments on finding opinions, like subjectivity analysis, but we also did some experiments on word senses, things that you can learn by looking at other languages. And we have some other work that we are doing with this idea in mind, that when you look at representations in multiple languages, you can actually do better than by looking at representations in just one language. Another project has to do with finding important information in large text. This is a project we've been working on. It's not really active right now, and that's something we're talking with Nina over lunch, finding keywords and building summaries for books. And more recently, a project that was related to that was to do text mining on large text on historical data. So we had newspapers covering 150 years and trying to find trends, patterns, and any interesting information there. So that's the sort of the follow-up to that project we had of finding important information in documents. And there are a number of other ongoing projects. I have one student who's about to graduate who focused on grading short answers. I have another student who's working on the connection between visual elements and text elements, how you can, for one thing, how you can annotate images better by looking at text around that. And the other, which I think is a more exciting direction, is how you can combine visual and text information for doing better at certain tasks, whether it's relatedness, classification, whatever you're trying to do, this idea of combining different modalities. And the more recent thing that I started to look at is this multi-modal work, and also differences between cultures, but that's something just mostly in the thinking phase, which relates to all this work that we've been doing on multilingual corpora. So that's for the introduction, just to give you an idea of the kind of work that we're doing in my group. So what I would like to focus on today is this project that we had on using Wikipedia for natural language processing. And there are several sort of spin-off projects from that, but I wanted to focus on the basic research that we've done. And I'll just point toward the end at some of the ongoing projects that build on this. And please feel free to interrupt me at any point if you have anything that's unclear or if you want to comment or just ask a question. Okay, so the main idea that was behind this project when we first started was whether we can, in a way, replicate the task that Wikipedia users are doing when they annotate the data. So how many of you are using Wikipedia? I'm not asking whether you believe that or not, or accuracy of information. I know that's a big issue, in particular in schools of communication or information sciences. How many of you contributed to Wikipedia? Okay, a few. So what we had here as a task is, in a way, to maybe assist people who are contributing to Wikipedia. So the kind of task that such users would have to do, which is, if you were to actually read the Wikipedia guidelines, there are very clear instructions, sort of, on what you are supposed to do when you create a Wikipedia article. For one thing, of course, is the kind of information that you put there, but then there are things that will tell you what are the concepts inside the article that are supposed to be linked. As you know, there are a lot of links between articles in Wikipedia. So here is just to illustrate the page that I just grabbed the other day about Rutgers University. So you would see there a number of concepts in blue, and those are actually clickable links. So if you click on one of those concepts, it would take you to the article corresponding to that particular concept, which would explain what that concept is. So what we would want to do is to do this particular annotation, like finding what are the important concepts in an article that are worth linking, right? You don't want to link every single word. Even if every single word would have an article on Wikipedia, you don't want to do that. And creating the correct link. Now, why would this be useful? In the first place, it could be a tool to assist Wikipedia contributors. So instead of doing all those annotations manually, you can use this tool in the first place and then edit the output of the system. But then there are also a number of natural language processing applications that could potentially benefit from something like this. We look particularly at text similarity and text categorization, but I know other people in other groups have looked at summarization, machine translation even. So there are a number of applications where it's useful to have this rich annotation that you get naturally in Wikipedia. One application that we look at in particular is how you enrich educational materials, and I'll talk about that a little bit at the end. It's more like a pilot study at this point. And also annotating web pages. So there is this big vision of the semantic web, which will mean that in addition to what you already have out there, which is text on the web, you'd also want to have some kind of semantic annotations. It's not necessarily that they have to be the kind of annotations you find in Wikipedia, but some kind of enrichment of the text there that would help you find information more meaningfully. So from a technical perspective, this is really a combined problem. So for one thing, you have to identify the important concepts in the text. This would be referred to in natural language processing keyword extraction. So you extract keywords. It could be words or phrases, more generically referred to as keywords. And then the second problem is, once you identify this important element in the text, you would want to link it to the correct page. And as it happens, many words in English are ambiguous, so you could have several potential pages that are would refer to that concept, but you will have to pick the one that is correct for this particular context. So that is really worse than disambiguation, like finding the correct meaning of a word so you can link it to the right page. So this is what our system looks like. As input, we can get any text. We'll eventually remove HTML tags or anything, so we really just need raw text. And then in the first stage, we'll do keyword extraction. And then the second stage, once we identify the keywords, we try to identify the correct meaning. And eventually at the end, we produce the same text as it was input, but this time with links to Wikipedia articles. So supposedly, the text that is entered into the system would look very much like a Wikipedia article because it would have links to Wikipedia. So I'm going to take one stage at a time and give more details and evaluations. And then at the end, I'm going to also show a couple of evaluations that we did of the overall system. Okay, so the first part, we want to identify what are the important words and phrases in the text. Typically, this has been addressed as a two-stage process. First, to identify all the candidates, words and phrases, so what would be possible keywords without necessarily ranking them in any ways. And then second, you try to come up with a ranking that will tell you this is more important than that. Now for the first part, candidate extraction, people use n-grams, so you can get sequences of 1, 2, 3 n words at a time, and those will be your candidates. You can also try to become a little bit more sophisticated and say, okay, I'm also looking at some linguistic structures, like for instance, sequences of 2 nouns at a time, or adjective followed by noun, and so on. For the second part, typical methods are information theoretic methods, where you calculate the frequency of a word on a page and divide with the frequency in a large collection of documents, and that will tell you something about the importance of that word. Or you can also use some kind of machine learning, where you try to learn from a corpus that is annotated, where you already know the keywords. You try to learn whether the position is telling about the importance of a word, whether the length, whether the linguistic structure, and so on. Some other features are useful for this. What we are doing, given that we work with Wikipedia, for the candidate extraction, we actually have a semi-controlled vocabulary. So given the fact that the words or phrase that we are going to highlight, we want in the end to link them to Wikipedia articles, we actually have, in a way, a simpler problem than if you were to work on just any regular text, because the candidate keywords are only those article names from Wikipedia. Since you are only linking, or that's the way we define the task, we want to link to existing Wikipedia articles. So that's in a way our universe. Those are only possible keywords. Those and also the surface forms. And by that I mean, you could have, for instance, an article, United States of America, and people will refer to that as USA, US, United States. So all these different forms are valid forms, and we account for them. But for instance, off as a word, if it doesn't have an article, we are not going to consider that. So that's not a candidate for us. Then for the second part, we look at different methods. The typical methods are the so-called TF-IDF. Again, term frequency inside the document divided by frequency inside the large collection. And that's in a way the most obvious approach to try to find keywords. Similar to that is chi-square independence of phrase and text, so also an information theoretic measure. And the one measure that we came up with, which is specific to Wikipedia as a collection of documents, is something that we refer to as key phraseness, which would mean what is the likelihood for a word or a phrase to be selected as a key phrase. And it's defined actually very simple. So we look at the number of times that we see a keyword, a certain keyword, whatever that is, inside Wikipedia, divided by the number of times we see that sequence of words, but it's not highlighted. So it's really like, for instance, for United States, how many times you see United States linked to an article, which means that somebody selected it as a keyword in that particular article, divided by how many times you see United States, regardless of whether it's linked or not, regardless of whether it was selected as a keyword or not. So that will tell you what is the likelihood for this particular candidate keyword, really, United States, to be selected as a keyword whenever it appears in a document. So obviously we wanted to see how well these methods are working. The nice thing about Wikipedia is that the annotations are manual, so you can actually use Wikipedia itself as a gold standard, so as a way to evaluate the methods that we are coming up with. We selected 85 documents with a total of 7,200 links. And these were selected by Wikipedia users, have undergone the typical editorial process on Wikipedia, so are considered to be good annotations. And we had, so on these particular pages, we remove all the links, and we had our system generate the candidate keywords. And those candidate keywords are compared against the gold standard, which would be the keywords or the links identified by the users, by the Wikipedia users. So based on that, we can tell how accurate is our system. And here are the results. So I'm showing here precision, recall, and F measure. just to make sure we are on the same page, precision will look at out of all the keywords generated by the system, how many are correct, again, according to these Wikipedia user annotations. Recall would be out of all the keywords suggested by Wikipedia users, how many my system managed to capture. And then the F measure would be the harmonic mean of the two. So it's, in a way, it's combining those two. So what you can see here is that typical information theoretic methods are doing reasonably well, probably better than they would do on just regular text, but still it's only at about 40%. Whereas this key phraseness method, which we introduced, is doing much better. So it gets to an F measure of about 55%. Now, the one thing to keep in mind here is that key phraseness, to some extent, is supervised. So it's actually learning from the annotations in the Wikipedia data, whereas the other two are not. But that's, I mean, that's perfectly fine. I mean, if you can learn from whatever data is out there, in particular, given that Wikipedia was not created or annotated for our purpose, I mean, it's just sitting out there. I think it's a nice result, the fact that you can actually use those annotations that were eventually created for a different purpose. It's just linking articles to other articles. They turn out to be useful for this task. So just to give you an idea of how these annotations look like, here is an article on United States of America. And on the left side, you have the links that were created automatically. And again, up to this point, I've been using links and keywords with the same meaning. So links or keywords with the same thing. So I haven't talked about meaning yet. So on the left side is whatever keywords we selected, and on the right side, you have the actual links created by Wikipedia users. And you see some differences. So one thing, for instance, which has to do with our system not really following the rules that are given to Wikipedia users is linking the title of the article. So if you actually read the guidelines, it will tell you that you are not supposed to link the actual title of the article, right? So if we were to follow that, we would link United States of America. Another difference there, for instance, is we linked Canada and Mexico, whereas the Wikipedia users chose Canada to the north and Mexico to the south, and there are actual articles that would talk about the border. So it's a more specialized concept. Now, which one is better or which one you should link, I don't know. I think it's, at some point, it's debatable.
Question. You may have explained this, and if so, I missed it. Typically, when you have a selection rule, you can make it more open or more restrictive.
Okay.
So how did you decide how restrictive to make it to do the scoring here?
Restrictive in the sense of how many items we are selecting?
Yeah.
We count, and that's something that I skip over, and I apologize. It's 6%, and that's something that we also learn from the data. So we figured that overall, out of the entire number of words.
So when you say you learned it from the data, was that by seeing how the F score got better and then got worse? Or?
No, so we had the test data, which was set aside, and then we had the remaining millions of articles, which were not part of the test data, which we used to, for one thing, to find the key phraseness. And another thing that we also looked at was what is the percentage of words on a page that is selected on average to become a keyword. And we found that from a total of, I don't know, if you have an article that is 1,000 words, 60 words would be selected as keywords. So on average, we found that about 6% of the words are selected of keywords, and we use the same threshold. So we have a ranking, and then whenever we reach about 6%, that's what we produce as output.
So that's what this is. The 6% is the common the number of keywords that would are typically found in the article.
Yeah, on average, and of course you find differences, but on average that's what you would find.
So when you say 60 words in the article, is that 60 keywords too, or like United States of America, maybe 4 words in that 60?
60 words, and that's why I say about, because we wouldn't cut a keyword or key phrasing in half. So when we reach about 6% counting words, then that's where we would stop.
Yeah, I have a question about that comparative, this slide. I noticed, for example, in the first line you have Federal Constitutional Republic, and in the automatic version, the federal was not included. It was just Constitutional Republic, right?
Okay.
And in the article that Smara had recommended that we read, Wikify, by you and your colleague, you were saying that in the automatic version, you chose as keywords tree ferns, for example, and carboniferous. But it wasn't clear to me why, in the case of tree ferns, the phrase was automatically picked up, but in the case of carboniferous period was not picked up. How does the automatic system decide when to go with the two words and when to just stay with one?
It will pick, so candidates can be anything that is listed, appears as an article in Wikipedia. So it could be single words, 2 words, 7 words. I don't think they are.
How does it know which is the best one to go for?
It will take them all as candidates.
Ah.
So as candidates, most likely we also had, because apparently Federal Constitutional Republic is also an article. So as candidates in the generation, like in candidate extraction phase, we had Federal Constitutional Republic, one candidate, Constitutional Republic as another candidate, maybe Republic as yet another candidate. And then among these 3, we try to find which one has the highest key phraseness, which one is most likely to be selected as a key phrase, and we came up with Constitutional Republic. Although the other 2 were also considered, but they didn't make it because they do not have as such of a likelihood to be selected as key phrase as Constitutional Republic has.
I see. Thank you.
Other questions?
I'm still not quite sure why, so there's an article Constitutional Republic as well as an article Federal Constitutional Republic, and it wasn't sure whether to include the federal or not. I'm trying to...
It considered both. So it would consider all sequences of words that appear as articles in Wikipedia. And then from all those, it would select the one that is most likely to be selected as a key phrase according to that formula I put. So how many times it was selected as a key phrase divided by total number of occurrences in the entire Wikipedia. And so Federal Constitutional Republic apparently has a smaller number according to that formula than Constitutional Republic.
Okay.
So it's really very simple, but turned out to be effective in this task. Okay, so if there are no more questions, I'll move on to the next stage. So at this point, we have keywords, key phrases. Again, I'm switching between those terms, but I'm really referring to the same thing, that were extracted from a page. And the next challenge that we have is how to find the right page to link to. And the reason this is a problem is illustrated here. So here are some extracts from pages in Wikipedia. And some of these examples might not find them exactly. As you know, Wikipedia is continuously changing. So if you look exactly for this, maybe there is a word that has been added since I put together the slide. So, but the main idea is still there. So here is an occurrence of the word bar in the page for Aida Cafe. It's saying in most shops a quick coffee while standing up at the bar is possible. Here is another one which also refers to the word bar, and it's part of the explanation for channel. So it's the article for channel. It's saying a channel is also the natural or man-made deeper course to a reef, bar, bay, or any shallow body of water. And here is yet another one where you have again the word bar, but this is the page for meter. It's saying each bar has a 2-bit unit, 5-bit unit, and 3-bit unit, and so on. So the one thing to notice here, which is a very prevalent phenomenon in language, is that although the surface form is the same, it's still bar, it actually has different meanings. And when you actually look at the link, which is the key observation here, so when you click on the link that is available in this article, it will take you to the page that describes what the bar is in the meaning of bar counter. So it's a place where you sit at the counter and have some drinks on. So the main idea behind using Wikipedia for finding the meaning of words is that when you actually look inside this example that I just showed, you will see explicit annotations. So whenever you have links to articles, although again the surface form would look the same, so you still have bar, bar, bar. When you actually look at the annotation, the link inside Wikipedia, you would find different things. So in the first example, you would see bar counter. So it explicitly tells you this should go to the page for bar counter. In the second example, you would see bar length form. So again, explicit indication of the meaning of the word. And finally, the third example would be bar music, so another label. So really, when you look at it this way, it was some form of revelation that I had, and I was excited for the entire summer when I figured this out. Again, it's a very simple thing, but I think it's exciting that Wikipedia, when you look at it this way, it's a huge annotated corpus. And again, it wasn't for the purpose of words navigation. Obviously, all those people are not writing Wikipedia articles to help, say, me or somebody else in their research. But it's, in a way, a side effect. The fact that they had to explicitly indicate the correct article when they annotate these pages. And of course, you find the exceptions, and that's something you'll have to look at when you run any kind of experiments, like links, for instance, that would take you to a disambiguation page, which is a page that doesn't really help you understand the meaning, or wrong links, or those of exceptions. But overall, you have millions and millions of annotations that are very rich for this particular task. So one thing that you need whenever you try to find the meaning of words automatically, if you were to go the data-driven way, is that you need annotated data. So the annotated data is here because you have all these annotations. The other thing is to look at sense inventory. So sense inventory will be really what is the listing of meanings that would be considered by the algorithm. So what are all possible meanings that I want to consider, for instance, for the word bar? So one approach for that would be to look at disambiguation web pages. And one issue we had with that is that they are not very consistent. For instance, sometimes a disambiguation page would be indicated with the label disambiguation, but sometimes that label is not present. So if you wanted to use an automatic way to figure out what are disambiguation pages, you're always very successful on that. The other, which is the way we use in that work, we are now trying different alternatives in an ongoing project, but what we use in this particular work was to map the meanings that we find from Wikipedia to WordNet. WordNet being a English dictionary that has senses with definitions and examples. And this mapping was done manually, so that's in a way a criticism for this work, that we have this manual mapping that we need to do. So to give an example, this is really what we are doing. So first, when you are given a word that is ambiguous, like bar, you would first have to extract all the examples in Wikipedia that mention that word and where that particular word is also linked to the article. Then you would get all the possible labels that have been used by the Wikipedia users, and then map those to WordNet senses. So with that, we have a collection of examples where we have explicit senses for the word that we target, so that we can train some machine learning on that. So here is again the word bar in the first step, and again this refers to a somehow older version of Wikipedia than what you would find right now. So if you were to do it today, probably you'd find even more examples. We found 1,200 paragraphs that contain the word bar. Then we looked at all possible Wikipedia labels, which would be the left component of a parenthesized annotation, the kind of annotation that I showed you. And we found 40 Wikipedia labels, and here are some examples. And finally, when we mapped those to WordNet senses, then we came up with 9 different WordNet senses. And here are some examples of the word sense, the Wikipedia label, and sometimes you see that you can find different labels just because people are not always very consistent, or just because they are different ways of referring to the same thing. Like for bar music, you would also find measure music or musical notation as a possible annotation. And I'm also showing, just to illustrate, the definition in Wikipedia and the WordNet definition. So we apply supervised words navigation. This means that we use all this data that we have in Wikipedia to to train machine learning, meaning that we try to extract some features, like simple things like, say, the current word, words to the left and right, some words in context. So this would be the feature that would go to the machine learning algorithm. And based on that, the algorithm would eventually learn what is that makes, for instance, the meaning of bar music. I mean, what are the things that usually happen the word bar when bar has the meaning of bar music? The same would be for bar counter and so on. So the experiments that we've done were on SenseEval 2 and SenseEval 3 data. These are some evaluations that are run every 3 years for various tasks in semantics. And we use 49 ambiguous nouns and then remove the ones that had only one Wikipedia sense, and also those that had multiple senses, but eventually after the mapping to WordNet only came up with one sense. So when there is only one sense, obviously there is nothing to disambiguate there, it's all very clear. And the final set was 30 nouns that had Wikipedia labels. And we did tenfold cross-validation, meaning we took the entire data for one word, divided in 10, we trained on 9 tens, and then tested on 1 tenth, and then repeated this process 10 times. And here is the results that we got. I'm just showing some examples for a few words, and then the average line refers to all 30 nouns that we use in these experiments. So on average, the words have like 3.3 senses. On average, number of examples are 300. The most frequent sense, so if you were to always pick the label that is most frequently selected for that one word, would already give you 72%, which is fairly good. But then when you do the method that I showed, where you extract the examples and actually make an attempt to learn something about the context surrounding an ambiguous word, then you can do quite a bit better. So we got 84%. Some notes here, some words perform poorly, and when we look at the data, it turned out that, for instance, they had very few examples. These are a couple of examples: restraint and shelter. They only had very few annotated examples, so we couldn't really learn much from them. Another example of a word that had a very large number of examples, bank, so there were more than 1,000 examples. But then when we look at the distribution of senses, it turned out that the distribution was very skewed. There were 1,044 occurrences of bank labeled as financial institution, and only about 30 labeled as river bank. So again, it was very difficult to learn something from that. I mean, the algorithm was mostly learning that if you go with financial institution, you are safe, and it would just ignore the river bank. And we also did another experiment where we used the same data set that I mentioned in the keyword extraction. So one evaluation focused on few words that were known to be ambiguous, were words that people in natural language processing have also focused on as being ambiguous words, difficult words. In the other evaluation, we tried to look at all the words. So we'll take, as before, a set of pages from Wikipedia and use the annotations from Wikipedia and use that as the gold standard and see how well we can do there. So here we had 85 documents, the same as before, 7,200 links. And we look at 3 methods. One is supervised, which is the one that I mentioned, where we try to create some annotated data for each word and then try to determine the meaning by using a machine learning algorithm. The other one is similarity, which would measure the similarity between context and the candidate article. And the third one would be a combination. And here is what we got. So the leftmost column would refer to the random baseline. So that means that for every word, I would randomly pick a sense. The next one, green, would refer to the most frequent sense. So for every word, again, word or phrase, in my data, I would pick the label that is most frequently selected in the entire Wikipedia corpus. The orange columns would tell you what is the accuracy of a system that would look at overlap, how many words there are in common between my current context, the article that I'm looking at and trying to disambiguate, and all possible meanings that were found by the Wikipedia users, like their corresponding articles. The yellow column is the worst ambiguation system that I mentioned that does some learning. Again, it's nothing fancy there. I mean, we didn't go out of our way to try to put syntactic features or other sophisticated features. It's really very simple looking at surrounding context, but it does do some learning. And finally, this last one, the gray one, is a combination. So it's one that could do simple voting. If the similarity and the supervised system would agree would output that label, otherwise would refrain from saying anything. And you see you get different numbers. The most precise system is the one that combines similarity with worst ambiguation, so you can get close to 95 precision, but of course you lose on recall, so you lose on coverage of how many words you can disambiguate correctly. But whenever the system says something, then you are doing reasonably well.
So there's something interesting here about the fact that when the yellow supervised system is combined with the orange system, which is worse than it is, the combination performs better.
I wouldn't make that statement. I think it's getting more precise because I'm only looking at agreement. So if you look at all of them,
drop the ones where they do not agree.
Yeah, so F measure, which is the one that combines both precision and recall, is actually worse. If you compare the gray column with the yellow column. But only, again, losing on recall, losing on coverage, you can be more precise. But overall, I wouldn't make that statement that it's not doing bad.
In terms of kind of statistical error bar, is the combined method measured by F any different from choosing the most frequent sense?
I don't know the answer to that. I would say so just by looking at things, but I'm still a bit puzzled about how to do those statistical bars on F measure. I don't think it's very obvious. I mean, not obvious to me.
Do you have any gut feeling for how frequent something, you mentioned like some of these, there were two issues, one of not having enough instances and also the skewedness of the distribution in the census. Those are the two things.
I haven't looked at that.
And I'm wondering how many instances
scale.
do you need before you can get some reliability?
No, and that's a study that we'd like to do. I haven't done much on that, but I think those are interesting analyses one could do to get a better feeling of how far you can get by using this kind of data. Okay, so I'm getting closer to an end. The only remaining thing that I want to mention, so we had these two components and we try to evaluate each independently so we get a feeling of how well each of them works. And eventually we also did some brief experiments trying to see how the whole system is working. For one thing, we put together this interface where you can wikify your data. So you either put a URL or just raw text and it will try to find the links there. And we also did two other evaluations. One was, I think the name is very fancy to say Turing, but it's in that spirit, so it's a Turing-like test. And the idea here is whether you can have a human tell apart the output produced by the system versus the actual human annotation from Wikipedia. So similar to the kind of thing that you saw before, in addition to keywords, we also had the links to pages. And so we had this, for the same article, we had the automatic annotation and we had the manual annotations, and we asked users whether they could indicate which one was the one produced by the computer. And we had 20 test subjects with mixed background, 10 document pairs for each subject, which were randomized, like the order was randomized, and average accuracy was 57%. Now the one thing to keep in mind, which when we submitted some papers on this, it wasn't always obvious to the reviewers, was that ideal case is 50%. So because we do 57, I think we're doing very well. It's not because it's close to 50, it's a poor result, it's a good result. So the ideal result would be when there is total confusion, then you get 50%. We are not there, so people can still tell apart the two, but it's getting close to that.
What were the
what were the subjects or participants actually asked to do?
They were asked to look at those two documents, like the two Wikifikations, and indicate which one was created by a computer. And they were told that they could do whatever they wanted. They could just look at the document, they could click on the links. We didn't enforce what they were supposed to do. So the task was to come up with with an indication which of the two documents were produced by a human and which was produced by a computer, but we didn't enforce any.
Did they have the possibility to say, I don't know?
No, that was not an option.
That's actually part of the Turing test, right?
Well,
That is the essence of the Turing test. I don't know.
Well, I don't know. I think it would be when
I mean,
you're
it's
confused.
not yes or no, it's I
Right.
don't know. Yeah.
Well, one doesn't know. Perhaps in a great many cases, they would have said, I cannot.
I think when they confuse it, it's in a way it's an implicit I don't know because they didn't know. But
I
it's
have
not.
a question. Did they know the Wikipedia rule that the title of the subject is not annotated?
Not necessarily. So I mean, they could do whatever they wanted. So if they were Wikipedia user, they would have known, but it's not a must. So we didn't tell them to read the Wikipedia guidelines or anything like that. So
That's the most obvious way to, I mean.
well, in this particular
Yeah.
case, yes, but in some other cases we didn't necessarily. So it's not always the case that would, like in the example I gave, it's not always the case that our system would highlight the title. So
Okay.
sometimes it might not. So.
Oh, it's also important perhaps for you to mention that you gave them both versions next to each other rather than giving them one and saying is this machine or not. They could actually compare, right? That's
Right, right.
that's important
right.
to say.
Yeah, they could compare. So they got both. Sometimes the human produced was first, sometimes the computer produced was first. And finally, another experiment that we did is just a small experiment to see whether this information is useful for learners. We use this Wikifier to try to enhance access to background knowledge. And we had a test consisting of 14 questions from a quiz that was given in an online history course at University of North Texas. These are multiple choice questions. And what we did, half of them, so 7, were linked to Wikipedia using our system, and half were left as they were in their raw format. And we had 60 students who took the test. And they had to to answer the question. They were allowed to use any information they wanted, and this is the same kind of instruction that the students actually take in the quiz in the real life setting received. So they could use whatever they wanted, but had to answer the questions. And they were not required to use the Wikipedia. So if they wanted, they used them, if not. And this is an example. So Louis spoke urban to addressing at Claremont with the 4 multiple choice questions and the links that were produced there. And what we found, and again, since this is just a pilot study, there are no big claims, but what we found was that on average, the students who used on average, whenever the questions were wikified, the answers were correct more often than when the questions were not wikified. And also, on average, it took students less time to answer the questions that had the Wikipedia links than those that did not have them.
So this suggests that someone else might try to write a program that tries to answer Wikified questions correctly and take the student out of the loop.
Eventually, I don't know if people use it in question answering. I mean, I don't know of any problem, but yeah, eventually. Yes. And again, I mean, I'm not trying to make any big claims. It was a small experiment that we ran that eventually it is useful to have that. And we have now an ongoing project on larger scale, multiple languages. And part of that project, probably in a year or 2 from now, we'll run a larger scale experiment where we'll see whether this kind of information does help.
60 students may not be enough for this, but is there an interaction between the value of the Wikified text for the students and the accuracy with which the students are answering the question? I ask because there's a claim about reading books online versus on paper that students who aren't very good do better with traditional paper, and students who are very good are interaction, if it turns out that the gain using the Wikify articles are, if those gains are noticeably larger or smaller for the students who are basically answering questions better or worse.
So I don't know if that's the answer to your question, but overall the questions that were wikified were answered correctly in a larger number
I'll
of
take it
cases.
up later.
Yeah, maybe I'm not understanding.
The question is, some people read well and some people read poorly. Does that make a difference in how they're helped by the wiki?
I don't know. So again, that's why I'm emphasizing that it's just a pilot study. We didn't really look at all those differences. We just had like one class, and it wasn't even a class of native English speakers. It was like whoever was willing to help us with this was in Hungary, and the students knew English, but they were native English speakers. So that may make a difference too. I don't know. So there are all these variables which I think are very interesting to look at, but we haven't. So the lesson learned, for one thing, Wikipedia can be used for natural language processing tasks. We specifically look at keyword extraction and words and disambiguation. So you can, as application and enrich education materials, like I said, we are hoping to make a larger scale experiment along those lines in a couple of years from now. You can also use them in applications like summarization, text adaptation, topic identification. And these are actually the ongoing projects in our stop. So we are trying to, for one thing, do text adaptation. That's a collaboration that started with somebody at ETS, trying to find words that are interesting to look at in a text, and eventually coming up with some definitions and synonyms or translations for that. Also finding the topics of documents, so using these links that we identify in the document, you can actually come up with the topic of that by doing some algorithms on graphs. Like even if, say, cold war is not mentioned in the document, you can infer that the document is about cold war because of the other entities that are being mentioned. And also, we have a project we started last year, and it's ongoing, on building multilingual semantic networks. And again, based on Wikipedia and doing some of the work that I mentioned today as an initial step, we are trying to come up with this large semantic network that would have multilingual concepts with their multilingual representations and the relations between them. And eventually, this information is learned from multiple Wikipedias, not just the English Wikipedia. So, thank you for your attention. Any other questions?
Yeah. Did you get any qualitative data out of your Turing test thing by talking to the participants to find out why they picked or didn't, why they assigned machine versus Wikipedia to the results? Why they made the decisions that they made? Did you actually interview people afterwards?
No. And I think for that it would be interesting to do, again, a larger scale experiment. I mean, you can get some input from 20 people, but maybe not enough people to actually make significant changes to the algorithm. So that's something we'd like to do, but on a larger scale again, whenever we will be able to afford that.
Was there some kind of a control group for the Turing test? How do you know that they didn't just answer randomly?
Well, I would assume the random would be 50%. So
And that's the design, and that's the ideal result
right,
as well.
Right. So it's just an assumption by statistical randomness what it is random. I didn't try to ask people to choose random or anything like that to see like a control.
Okay, but Nir's question raises a very serious problem. If some of the students were just guessing, you don't know whether that's because it's hard to tell them apart or the students were lazy.
We always have this problem, I agree. They weren't mechanical Turks, so I mean, they were sort of trusted humans, so people we knew, but of course they can always do that. So yeah, it's a matter of how much you trust your annotators or the participants. I agree with you, so it could be that they just randomly selected because they were bored with the task.
Just as for amusement, because you were just a mechanical Turk, there's a study in which somebody sent out a questionnaire and seeded it with the question, while watching television, have you ever suffered a fatal heart attack? never, sometimes, frequently. And 2% of the mechanical Turk people check something other than never, but 6% of the students in a class in a Midwestern university check something other than never.
I think there are big issues, and I'm hearing more and more with mechanical.
Do you know what percentage of the Wikipedia annotations are inconsistent?
Inconsistent in.
Well, you mentioned like paper that they had a case where it was for disambiguating the thing in one instance but not in another.
In that respect, I don't know. I mean, that was something that I observed by looking at the data, but I haven't, because if I would have done that automatically, so I'm able to actually indicate what percentage of the pages are inconsistent, then I would have known which. I mean, I could have solved the problem, but I didn't.
But,
So it's only
how many
automatic.
are missing information with the thing that could have been disambiguated but were not?
You are saying like links that would have been.
Yeah, that you should, here. So like, suppose you have an instance of bar, and it should be bar in the drink sense or what candy bar, whatever. What percentage of the instances of bar or bank or these ambiguous words are actually have an annotation?
I think, well, I don't have an overall answer, but I mean, I have it somewhere. I don't have it on top of my head. But we did do some kind of, for instance, words that had the word itself as a label, that's useless because it doesn't really have an indication of the sense. And I have it somewhere because we removed those cases as not useful for our purpose.
Isn't it the case that you, in your data, I thought I saw for, I don't know, was it bar or one of the words, like 1,200 instances and
Yeah, that's the
1,000 that were ambiguous, that didn't have.
Right, but like that's why I was saying I don't. I
Right.
have the data somewhere. Right here, I have it for the word bar, so I can show it to you. But I don't know it for other words. But I have it somewhere.
Okay.
So this might be an indication.
There.
Here.
Wait,
So
wait.
for this
Right.
one case, from 1200 to 1100, we're good.
Okay.
Yeah.
But it's just one instance, so that's why I didn't want to give this.
So but that at least with bar it says a large percentage of the ambiguous words actually have these annotations.
Right, right.
So then the question is like, if you want to move this to the multilingual settings, I think your method will work very well because I think it's easily portable to all the languages. The only question is about the nature of like how people annotate in different languages on the Wikipedia that have the same disambiguation.
So in theory, it's easily portable. The one issue that we run into right now, and we are still trying to solve, is the fact that you do not have the same sense, the same sense inventory, the same number of senses for a certain word, even if there is a mapping, because you have those multilingual links on the side of the page in Wikipedia. You still don't have consistency because in some languages maybe that article for a certain meaning is completely missing, and so you have this problem where you have multiple representation, but in some representations, some cases are missing not because they don't exist, just because they are missing. They are not there yet. And that's the one issue that I haven't really envisioned when we actually wrote the proposal that funded this project. That there is this issue of different meanings and how you map from one language to another, because in some languages you just have missing information. But yeah, I'm hopeful. So the one big idea that we are trying to explore right now is what I mentioned at the very beginning, where the fact that you have multiple represented multiple languages, hopefully it would help us do even better. So we'll see.
What about the problem of mapping from Wikipedia senses, the sense inventory, from Wikipedia senses to WordNet senses? What are your thoughts about it? This is all done by hand right now?
Yes.
So scaling that up to 10,000 or more words, and how?
There are groups that have done that automatically, and I cannot tell you exactly the accuracy, but there is a group in Spain and a group in Germany who they've been working on this automatic mapping, and it's possible with some errors, of course. But
There are real hesitations about WordNet. One of my students observed that WordNet didn't have kitten and cat in the same category and threw it away in disgust and said, I've never used it. The serious problem is that it's not nearly as finely divided as most good dictionaries. So you have to decide how important the precision is.
It's both. It makes distinctions that you don't find in dictionaries that are not necessarily
Oh,
good
it's
ones,
not
and it doesn't make distinctions you might like it to make.
I mean, one of the things that baffles me, 20 years ago, I tried to persuade Oxford University Press to put out a pair of a dictionary and a thesaurus. They already published many of both, but to put out a pair where every sense in one was in the other and they were cross-linked. And they didn't think it would sell, so
And Longman has.
Sorry?
Longman did it.
Longman had the OALCC, no, sorry, LDOC, yes.
But it's more that they you know.
Yeah.
At the beginning, you said that you did some kind of a keyword expansion. So, can you describe it? Elaborate?
Keyword expansion?
Yeah, like the United States, USA, and so on.
It's really not keyword expansion. If I use that term, then it's not really keyword expansion. It's like when we list the candidates, so extraction of all the candidates, we use all those forms that we see. So although the article may be United States of America, that's the title of the article, in addition to that, we'd also use all the forms that have been used on other articles. Whenever somebody pointed to the United States of America article, they might use USA, and then the link would be to United States of America. And there are people in other groups who use this as a source for synonyms, for instance. We haven't really done any expansion, just listing them all. So we list whatever we find as surface forms in the articles and the title of the article. Those were all listed